Hello everyone, welcome back to this video series on clinical SAS TFL programming. In this video, we will take a look at one of the disposition tables which is titled as Summary of Analysis Sets. The layout of the table is like this. The title is Summary of Analysis Sets and we are being asked to generate this table based on the randomized analysis set subjects. So we are summarizing the table in terms of the individual treatment levels and a total column. And then we are presenting the number of subjects in each analysis set and the percentage of subjects in each analysis set. We have some notes on this table which says percentages are calculated based on the number of subjects in randomized analysis set. And then we have another note which says do not present percentages when the count is 0. And we have a third note which says present all rows in the table even when there are no subjects who meet a particular rows filter condition. So say for example, if we do not have any subjects in per protocol analysis set in any of the treatments, so we still need to present this row and present the frequencies as 0. Now let us move to the programming aspect of this table. So what I have done here is I have my input data available in a SAS program. In the specified program and SAS path, I have included that file here. So when I run this %include statement, I will have the SAS code available in that program will be executed and all the data sets that gets created out of this program will be available in this session. So before that, let us write two housekeeping statements. The first one is for clearing our log window and output windows, and the second one is clearing work library datasets. So we can clear the log and output windows using DM statement. For clearing the output, we need to specify output semicolon clear semicolon and then log clear semicolon. So for killing the work library datasets, we have added an abbreviation called pdkill. So we have that code now available with this one. So we are deleting all the work library datasets and then we are including our input data file here. So let us run the code till this point in time and examine the log and see what are the datasets that are getting created. So here we have a dataset called ADSL created and there are 5 observations in it. So let us quickly examine the number of variables and names of variables using proc contents for this ADSL dataset. So let us run this code and then see the output. So we have our output. So there are 6 variables in this. One is FASFL per protocol flag, RANDFL which is randomized analysis set flag, safety flag, plan treatment and use of ID variables. So let us now take a quick look at the unique values present in all of these variables. So we can make use of our procfreq abbreviation and then the input data set is ADSL. As I am interested in checking the frequency or the unique values in all the variables, I just need to remove any of the table statements. If I do not give any variables on the table statement, if I exclude the table statement altogether, proc frequency by default gives us the frequencies of all the variables. So let us execute this code and then see. So let us clear the output window once and then try to execute this once again. So let us go all the way back to the top. So we have useObjd variable. There are 5 subjects in it and there is randfl. The values present in this variable are n and y, and safety flag. The unique values present are n and y, FASFL n and y, pprotfl as n and y. So now we have examined the unique values and also examined the names of the variables. So let us go ahead and program the table. So the first step that we do is read and process the input data set. So we have seen in the table title that this has to be based on our randomized analysis set. So let us filter for only the randomized analysis set subjects. And then as we need to create a count the subjects under total column as well, let us replicate the rows using TRT01PN output. And then so we had values of 1 and 2 in TRT01PN. So but as per the TFL shell layout, three treatments were possible. Let us assume that the third treatment would be named or given a number of 3 in the TRT01PN. So in order to create total column, we already have used three treatment values, which is 1, 2 and 3 for the existing study related values. So in order to replicate for total column, let us use a value of 4. So now we have replicated our rows for total column. Let us execute this piece of code and then see our log window and then see. So there were only out of 5 subjects present in ADSL, only 4 subjects were in randomized set. So there were 4 observations read with the filter condition of randfl is equal to y. So as we are outputting it for the total column, each of the row gets replicated. So 4 will now become 8 observations. So let us examine this output data set called ADSL01 and see what is happening. So we have outputted each subject twice. For the first time we have used the value from TRT01PN in the treatment variable, and the second time we have used the value of 4. So similarly for subject 1003, TRT01PN had a value of 2. So on the first row that got outputted as the value of 2 in treatment variable. On the replicated row, so where we have assigned 4 to the treatment variable. So each subject is replicated so that he can be counted under a value of 4 in treatment variable, which is nothing but our total column. So we have handled that. So the next step that we need to do is to fetch our denominators. So get our, which denominators are nothing but the treatment totals. So get treatment totals and create macro variables. So we can, let's first create a data set for dummy treatment totals. So because we do not have all the subjects in all the treatments in our existing data. So we can make use of do loop, do treatment is equal to 1, 2, 3, 4, and then an output statement within that, and then this one. So if we execute this piece of code and then examine the log and then move to the output data set, we see we have created one row for each of the possible treatments in as per the study design. So now let us fetch the actual treatment totals. So if you are following my previous videos, the processing is always similar. So we need to get the treatment totals and then we need to get the, so we'll create a dummy data set, we'll get the actual totals and then we merge our actual with dummy. So now we can use our proc freak to get the actual treatment totals. Our input data set is ADSL01 and then the frequencies can be obtained on the treatment variable. So let us call this data set as TRT total 01. So let's rename the count variable as TRT total. So and let's also drop the percentage variable in this data set as we do not need it. So in the next step we need to merge our dummy and actual treatment totals. So we can do that using a merge. So for merge, I have added an abbreviation of p merge. So I have that obtained now. So the first data set that we need to use is dummy treatment totals, and the second one is TRT total 01. And let us name the output data set as just TRT totals, and the by variable is treatment. So again, here if a record is present in only dummy but not in treatment totals, so we need to set the treatment total to 0. So we have done that. So let us now run the entire piece of code till this point and then examine the output data set TRT totals. So we now have all 4 rows, and for the treatments which are not present in the data, we have the treatment total as 0. So we had 2 subjects in treatment 1 and 2 subjects in treatment 2. So as expected, so the total number of subjects are a sum of the values present in TRT 1 and 2 and 3. So 2 plus 2 plus 0 is 4. So the numbers are coming fine. So and the next thing is that we need to get the counts for table body. So here, similar to how we have done it for in earlier tables, so we will make use of proc SQL to do that. So here we have 4 rows. So we'll and the filter condition for each of these 4 rows is different. So we will make use of proc SQL to process the data for individual row and then append them using union all car. So let us come back and then write a proc SQL step. So let us create this output data set as count01. So we need to identify the counts for each row. So for that I'll create a variable called order, one as order, and then we need to select treatment variable, and then we need to count a subject only once, so we can make use of use subj id with distinct keyword, and then let us create a variable as count to store the number of rows in this one. So the input data set for this one is ADSL01. So we for the first row the filter condition is randfl is equal to y. So we need to group the counts based on treatment. So let us run this piece of code and then see how it works. So we have 3 rows and 3 columns created. Let us examine count01. So we are identifying the counts for randomized analysis set with a value of 1 in order variable, and on this we have for first treatment we have 2 subjects, second treatment we have 2 subjects, on the total we have 4 subjects. So now let us replicate this entire piece of code for second row. So for that we are just trying to append the results from the second query to the first query. So 2 as order, these things still remain the same. For the second row, the population that we need to count is for full analysis set. We have seen that the name of the input variable for full analysis set is FASFL. So we need to change this filter to FASFL. Similarly, we can replicate this piece of code for the third row. So let us change the order variable to 3. So let us come back and see what is the third row meant for. The third row is meant for safety analysis set. For that we just need to replace the flag with SAFFL is equal to y. And then let's replicate this piece of code one more time for our fourth and final row. The fourth and final row was for per protocol analysis set. So the name of the variable for per protocol analysis set is pprotfl. So let us try to run this entire piece of code and see if log is clear and if everything is working fine or not. So log is clean. So let us now open count01. So we will have rows for treatment 1, 2, 3 and 4. So we have these counts are based on the data present in our input data set. There are some treatments absent in the input data set or some treatments which do not meet the filter condition for a particular row. So for example, we do not have any subject in treatment 2 who meets the filter condition for per protocol set. So we do not have a row for that in our actual counts data set. So but as we need to present the rows for all treatments, so we need to create a dummy data. So create dummy data set and then merge with our actual counts. So create dummy data and merge with actual counts. So how do we do it? So we can make use of a data step. Let's call this as dummy01, and then let's create a variable called label and then use a length of 200 on it. And then so what we need is 4 rows. So we have used this variable called order to identify the counts for each row. So we'll have to create a dummy variable with the same one. So the label for first row is, so let us go back to the shell and then fetch that. So the label for first row is randomized analysis set. So I am copying that and pasting it here. So let us replicate this for 3 other rows and then write a run statement, order 2, order 3, order 4. The second set is for full analysis set and the third for safety, and let me just copying this per protocol. So as the other things are short, I'll just type them here. So I have now created a dummy dataset to contain 1 row per each treatment, 1 row per label that has to be displayed. So but we need this to be replicated for each treatment so that we can populate the zero counts for the treatments which are not available at its in our input dataset, counts dataset. So we have created our label. So let us replicate each of these rows using a data step. So let us use dummy01 as input and create dummy02 as the output. So we can make use of a do loop to replicate each of these rows for all 4 possible treatments with an output statement within the do loop. So let us run this piece of code, check our log. This ran fine without any notes or warnings or errors. Let us open this. So we had 4 rows and with each row is replicated now for all the 4 treatments. So 4 multiplied by 4 treatments. So we have 16 rows. So now we have got our full template which each row for each treatment. So what the next thing that we need to do is merge dummy and actual things. So for that we just need to sort our dummy data set and actual data set. So we need to sort this data sets based on order and then treatment. So we can just replicate this sort for our counts01 as well. And then we need to merge these two data sets. So count01, let's create the output dataset as count02. Let's use dummy dataset as the first dataset in the merge. So the by variables are order and treatment. Again here, if a row is present only in dummy but not in actual, so let us set the count variable to 0. So let us run the entire code till this point in time and then see how our dataset. So we were expecting all 4 rows with 4 treatments. So 16 rows were expected, but in the actual data, we only have data which correspond to 11 such combinations. So in the output dataset, we have all 16. So let us open our count02 and then see if 0 counts are populated on the combinations where they were not there. So we have seen in the input dataset that there were no subjects which were corresponding to treatment 3. So if we examine this output data set, so on all the rows where treatment is equal to 3, the count variable should have 0 number. So 3 treatment 0 here, the second instance of treatment 3, 0, third instance of treatment 3, again count is 0, and then fourth instance of 3, the count is 0. So this is working as expected. And the next step that we need to do here is to get the calculate the percentages. So let us, for this what we need is to sort the TRT totals data set based on treatment, and we can replicate this sort for our count 02 as well. And then we need to merge these two data sets at treatment level. So we need to use the input data set as count 02, and then let's create count 03. The second data set that we need to use in the merge statement is treatment totals, and then we need to merge in the treatment. So we need to keep only the records which are coming from count 02 here, and then we can just run the entire piece of code till this point in time and see if everything is working fine. So here I made a typo. I missed the letter T after A in the treatment variable. So it is throwing us a warning saying that by variable treatment is not found in first dataset and second dataset. So let us fix that and then try running the entire code once again. So now that error is fixed. So now let us open our count 03 and see if we have our treatment total available side by side the count variable. Now we have the numerator and the denominator available side by side. We can calculate the percentages. Let us do that in a new data step. So we can in fact do that here in this step itself, but I prefer keeping it as a separate step. So let us create the output dataset as count04. Let's create the standard count percent variable as CP and use a value of use a length value of 30 to that variable. So here we were asked not to present percentages on when the frequency or the count is 0. So I am creating the CP variable to include percentage only if the count is not 0. So put of count. So let us use 3 dot. So and we need to put the percentage within the parenthesis. So I am using this open parenthesis here, and then I'll calculate the percentage within the put function by using count by TRT total multiplied by 100 and converting that to character format using 5.1 format. So I'll close the parenthesis after the percentage, and then else if count is equal to 0, we were asked to present only the frequency but not the percentage. So we have created our CP variable. So let us run this piece of code and then see how it is working. So let us open count 04 and see how our CP variable is looking like. So we have some rows with frequency is equal to 0. On that row we do not have the percentage concatenated as expected. So now let us come back, and in this till this point in time we are processing the treatments as rows, but we need the treatment combination to be displayed as rows, so displayed as columns. So for that we just need to transpose this data. So let us restructure the data to present treatments as columns. So for that let us just sort the data and then use a transpose step. So the input data set for this sort here is count04. So we need to sort the data based on order and label, and here the input data set for proc transpose is the sorted count04, and let us create the output data set as count05, and again let us use a prefix of TRT for the newly created variable names. So we need to keep order and label variables as columns, so we need to specify them on the label. The variable that needs to be transposed is CP, and the names of the newly created columns have to come from the variable treatment. So I am specifying that on the ID statement. So let us run the code till this point in time and then see how our final data set looks like. Before that, let's examine the log. Log looks all clean. So let us now open count05. So we now have our final data set which looks like the same structure that we need to use in reporting. So but we forgot one thing when we were creating treatment totals, so we did not create our macro variables. So let us do that here. Create macro variables. So for that we will use our data step. So the input data set will be TRT totals. So here we will make use of calls input x. So the calls input x needs two arguments. The first one will contain the names of the macro variables that have to be created, and the second one is the name of the variable into which from which we need to assign the value to the macro variable. So here we will create the names of the macro variables with a prefix of TRT to the value in treatment variable. So we have four rows in our treatment totals data set. So we'll get four variables created, four macro variables created with the values from TRT total variable assigned to that particular macro variable which is getting created on a specific row. So we have all macro variables also created. So now we can just create the report. So let us say generate report. So let us make use of one option, no center, so that our report gets aligned to the left. Otherwise, by default, the report gets aligned to the center. So let us start writing our proc report code. So proc report data is equal to count05 can be used as such, and then let us make use of no windows option. So and let us also make use of headline, head skip, and then let's use a page size of 30 and line size of 150, and then let us also make use of missing option, and then column statement. So we need order variable and we need label variable. We need TRT1, TRT2, TRT3 and TRT4. So now we need to specify the define statements for these all variables. So order variable, we need only it for ordering the rows but not for printing. So we have to make use of the no print option on the define statement, and then we need to define a width and other column labels for other treatment columns. So here for the first column in which we have the labels for individual analysis set, we do not have any label. So we need to give a null label. And for other things, those level 1, 2 and 3 and total are being used. So let us label them accordingly. So as we need to have a null label, we need to explicitly mention that within the codes. Otherwise, the name of the variable would be printed. So let us use a width of 30 for this column and also make use of flow option. So and then define the, so let's give a space and then define the labels and other options for individual treatments. So for this first treatment, so we were asked to use a label of dose level 1, and on the second line we were asked to present the number of subjects available in that treatment. The name of the macro variable that we had was TRT1, so let us make use of it here. And then on the third row we were asked to present this n and percentage statistic indication. So and then so let us specify a width of 15 here, and then also use the flow option. Now what we can do here is replicate this 3 more times and then change it for to treatment 2, treatment 3 and treatment 4. This is dose level 2, dose level 3 and the 4 treatment 4 is nothing but our total column. So here let us try to change the names of the macro variables also, which contains the number of subjects in each of those treatment. So we don't need any uh, break or these things after each of the rows, so we can ignore all of, we do not need any compute blocks or break statements. So let us run this entire piece of code and then see if it is working fine. Yep, it ran fine. So let us examine the output ones. So we had 2 subjects in first treatment, 2 subjects in second treatment, and there were no subjects in third treatment. We have it as 0, and there were total 4 subjects. So we have the total number of 4 subjects present here. So if we want to center align things, so what we can do here is we can add the center option on all individual treatment levels. So let us rerun this entire piece of code and examine the output. So here now we have seen that the all 4 randomized subjects were present. So as this table was based on randomized analysis set, we are expecting these numbers to match the column header. So 2, 2, 2 and 2. So 0 and 0, 4, 4 and 4. And then the percentage has to be 100 because this is equivalent to the number of subjects in the column header, as both are based on the randomized analysis set. And then the counts are there for different analysis sets. So we have completed programming a summary of analysis set table in less than 35 minutes. Thank you for watching. Keep learning.